Remember Optimus Quilt Shop? She bases her designs on quilt squares that can vary in size, so she calls the length of each side for the basic square x, so x, and the area of the basic square is x times x, or x squared. In this way, she can customize the designs by making bigger squares or smaller squares. Sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders 4 blocks of the basic size, they write up the order as 4x squared. Think about that. What would that look like? Well, if this is 1x squared, 4x squareds would be 4 separate quilts. Now, what we were doing last time, just as a quick review, is saying if we had one quilt and we had a x squared piece and 6 little x pieces, we wanted to know how many little ones we would be able to need in order to turn it into a square quilt. And what we saw was that if we took the 6 little x pieces and put half here and half here, that we could then fill in this corner into a square. So what we said was half the middle number, half the x's, which would be 3, and then square it, and we would end up with 9 little pieces that we needed to complete the order. And we did that for one quilt. And then we would rewrite that, if you remember correctly, as x plus 3 for the length, x plus 3 for the width. So we could also rewrite that order as x plus 3 squared because it's length times width. I wanted to remind you of that because now we're going to be doing the same thing, but we could have more than one quilt. Like in this case, we had 4 basic quilts. Okay, so one of the customer service representatives finds an envelope that contains the blocks pictured below. Write an order that shows 2 equivalent equations for the blocks. Okay, so if we think about it, we have an x squared, right? And then we have 1, 2, 3, 4, 5, 6 x's. So we have an x squared plus 6 x's plus 9 ones. So that's one equation for one block, but it wants 2 equivalent of equations. And again, this is only for one quilt. So another equation would be based off the length and the width. So let's think about it. This has a length of x, but this time we've added 3 here and x plus 3 here. Oh, it's the one we were just working on. It would be x plus 3 squared. Well, that's for one quilt, but how many quilts do we actually have? 1 and 2, right? And so we would need to put a 2 in the front of this. There are 2 of these or 2 of these. And if there are 2 of them, we could also just count up the separate pieces and say that is 2x squareds because 1, 2x squareds. Now do the distribution again. 2 times 6 is 12 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. And 2 times 9, 18 ones. If we were to add them up, 9 plus 9 is 18. So the idea is we can still do the same stuff we did with one quilt, right? Doing length times width to find an area equation, which would be this. But if there are 2 quilts, we'd need to put a 2 in front of it. Similarly, we could just add up all the pieces, but if there are 2 quilts, we'd need to double that or add up all the pieces, but twice. Okay, so what equations for the area could customer service write if they received an order for 2 blocks? So right away, these squares down here are just to help you. If we only need 2 blocks, we don't really need this square. We can just ignore it, okay? Now it says, both dimensions are increased by 1 inch in comparison to the blank base block. So here's our base block again, and we have 2 of them. But it's also supposed to be increased by 1 inch on this side and 1 inch on this side. And then if we were to finish it, there'd be a dot and a dot. So again, these boxes are just to help you not have to draw the pictures. And if you wanted, you could even erase those, although you can't do it on your paper, because that's actually what the picture looks like, right? Both dimensions increased by 1 inch in comparison to the base block. So now I want to rewrite this. Well, for one block, that is x plus 1, that's the length, times the width of x plus 1. So that's x plus 1 squared. But remember, there are 2 of them. And then if I wanted to combine it, I would say, well, there are 2x squareds, 1, 2, 3, 4 x's, and 2 blues. Or another way before you simplify it would be that there's an x squared plus 2 x's plus 1 blue, but that there are 2 of them. I had an extra x there. Okay, I want you to try that with this next step. It says, this time you have an order for 3 blocks, okay, and each block is increased by 2 on the side. So if I were to color it, I've got the base block plus 2, and the base block plus 2, but you would have that for all 3. So you're going to need to shade those in. And then I'd like you to try to do what I did up here, which is to write it in both directions. So remember, this is x plus 2 and x plus 2. You're going to have 3 of the blocks and see if you can write it in. Now, Clementine is at it again. That's the Optima's dog. When is that dog going to learn to not chew up orders? She also chews up Optima's shoes, but that's a story for a different day. Here are some of the orders that have been chewed up, so they are missing the last term. Help Optima by completing each of the equivalent expressions. So again, here's the idea. We've done this before for 1, but now we have 2. So we're saying we have 2x squareds plus 8x's, but before we can even work with that, we need to get it down into 1 square. So we have 2 of them. I know we have 2 of them because this is a 2. So to break it down into 1, I'm going to divide both sides to get 1 quilt. And in this case, I'm going to divide it by 2. So divide by 2, and 1 quilt. 2 divided by 2 is 1x squared. 8 divided by 2 is 4x. And now we need to fill in this little spot right here. Well, remember, we do that by saying half the middle number, which is 2, squared, which is 4. So we could add 4. And if you want to look at this picture, okay, we had an x squared. We had 4 x's, which we split in half. So we did 2 this way and 2 this way. And how many did we need to fill it in? 4 times 4. 4 turned into a square was 4. So this is a picture of our 1 quilt. But how many quilts did we really have? We had 2. So we're looking at this quilt again. It has a x plus 2 length and an x plus 2 width because it's a square. So it's x plus 2 squared, but there were 2 quilts. And then if you want to think about it, well, there were actually 2x squareds and 8x's. And if we added 4 to one of them, then total we would have had 8 little pieces. So you have to multiply back by the 2. And I'm going to let you do the same thing here. This time we had 3 quilts, so you have to divide by 3. So this is what you would get for 1 quilt. And I've even started the picture for you. And you just need to figure out the length and the width of this quilt, how many quilts, and how many little pieces. All right. Sometimes the quilt shop gets an order that turns out not to be more or less than a perfect square. Customer service always tries to fill the orders with perfect squares, or at least they start there and then adjust as needed. Now here's a real mess. Customer service received an order for this area. Help them figure out the equivalent. So really ignore these for a sec. This is what they got. They got 2 x squareds, 12 x's, and 13 yellows. So right away, since I have 2x squareds, I'm thinking, you know, it's going to be quilts. So I'm going to color in the x squareds. And then I have 12 x's, right? But I want to break it into two quilts. So if I did 6 for one and 6 for the other, that would help. So let's see, I could do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then how many yellow pieces do I have? Well, I have 13. I would need 9 for this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I've used up 9. I only have 4 left to be in here. Oh, wait, I'm missing. I would need 5 more to make it work. Okay, I would need 5 to make a full 2 quilts. Okay, so we want an equivalent expression for this, and here's how you can think about it. You could say, well, I have 2 quilts, 1, 2, and that's where I get this 2 from. Their dimensions are x plus 3 times x plus 3. So that's where I get this part from. But that would give me 2 full quilts, and I don't actually have 2 full quilts. I have 2, and I have 1 that's missing these 5 pieces right here, right? We really don't have those. So we'd say take the area of 2 quilts, but subtract 5 pieces, and that would give us the same expression. All right. So this next one, same idea. Okay, here's her pieces, and you want to figure out how it could be quilts. So you've got your 3 of these, that's what I've got to check off. Okay, if you have 6 of those, okay, you would need to do 1, 2, 3. How many would you need to do on each side? If you have 6, you'd have to do 2 for one of them. And I'm going to let you keep going. I'm going to tell you this is the combined total. Those are the loose quilt pieces. Okay. And what I'm looking for is the how many quilts. We already know it's 3. I'm looking for this thing, and then we plus or minus leftovers. So I'm going to let you try to do that from the picture. All right. So now we're going to look at the algebra. Optima realizes that not everyone is in need of perfect squares, and not all orders are coming in as expressions for perfect squares. Determine whether or not each expression below is a perfect square. Explain why the expression is or is not a perfect square. If it is not a perfect square, find the perfect square that seems closest to it. So here's the idea. Let's look at this one first. Is this one already a perfect square? Well, we could try to draw it, but it's harder to do when there's a negative. But we know that half the middle number squared would finish the quarter. Half of -8 is -4. -4 squared is 16. So yes, this would already be a perfect square. Okay, and you could rewrite that as x minus 4 on one side and x minus 4 on the other side. So it's x minus 4 squared. Okay, it's easier to draw the picture when the middle numbers are positive. This one, though, is not. Let's think about it. We have x squared plus 6x. And so we'd say, okay, half the middle number squared is 3. So we put 3 on this side and 3 on this side, because remember, making a square, so they have to be the same. And then 3 squared is 9. We would need 9 pieces in here, but we have 13, so we have some leftovers. So it's not a perfect square. Now this is how they show their work. Let me show you how I show my work. I want to turn it into, you can almost ignore this middle piece. I want to get it to this, like we were doing. Okay, and if you think about it, it makes sense because we needed 9, but we had 13 pieces over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If we used up 9 of them to go in this corner, we would still have 4. Again, this is a little confusing. Let me show you what I would do. I would rewrite it with this part in this beginning and then put a space and move the 13 over. And then I take half the middle number and square it, which is what I did here, 9. And I will add 9 here. And if I add 9 here, I need to subtract 9 here. And what you would get then is this will always turn into x plus half the middle number squared. And then, okay, we had 13 minus 9. We used up 9. We'd have a leftover 4. So I'm going to do one more of those with you. And then you can be done with this and just work on the homework. Here's my steps. Number 1, and this will show up again later too. Number 1, add a space. So I've rewritten it with a space. Number 2, okay, and you've seen these before. Do half the middle number squared. So half of negative 10 is negative 5, and negative 5 squared, negative 5 times negative 5 is positive 25. And you're going to add it and subtract it to both parts. So this would be minus 25. And then the last step is to square the first part and then find out what's left. This will always turn into x minus 5 squared, x, half the middle number, and the negative 3 minus 25 is negative 28. The only thing you might have to do with these is divide them first. Okay, I'm going to show you one more of these. We will practice this again in 2.5, but notice this one has 2 quilts. So we would have to, like we did before, divide it to get 1 quilt. And we did this a lot in class as well. And you would get x squared plus 4x plus 7. And now we do our steps. X squared plus 4x plus space plus 7. That's step 1. Step 2 is half the middle number squared, which is 4. And then I add it and subtract it to both parts. And then the last part is this will always rewrite as a square of x, half the middle number, half of 4 is 2, x plus 2 squared, and 7 minus 4 is 3. We would have an extra 3. But that is for 1 quilt. We had 2 quilts, so we need to go back and multiply everything by 2. So there are 2 x plus 2 squared quilts. And we would have actually had an extra 6 left over. So the only difference is to divide by the front, do what we do, and then multiply it back together. You do not need to finish the questions on this task. However, you do need to do the homework. Thank you.